This $90 steel tank will store energy for 30 years with zero degradation. No lithium, no cobalt, no capacity fade, no warranty that quietly expires while you are still paying for it. An ASME-rated propane tank manufactured this year will hold exactly the same pressure in 2055 that it holds today, and there is no chemical battery on Earth that can make that claim. That part is completely true, and I will show you the physics behind it. But I am also going to give you a number that almost no video on this subject will show you, and that number changes what you should build. By the end of this, you will know exactly how much energy that tank actually holds, what it can genuinely power, the 4 separate scales at which this technology has been proven since 1857, the full parts list with prices, and the one safety rule that separates a working system from a serious accident. Let me start with what you are being sold instead. The most popular home battery in America is the Tesla Powerwall 3. It stores 13.5 kilowatt hours and lands somewhere around $15,000 installed. Tesla's own warranty guarantees 70% of original capacity after 10 years. That is not the failure case. 70% is the number the manufacturer is comfortable printing on the document. Your solar panels carry a 25 to 30-year warranty. So across the life of that array, you are looking at 2 to 3 battery replacements, simply to keep using the energy your own roof produces. And it is worth understanding what sits behind that box before it ever reaches your garage wall. Lithium is extracted from brine operations in the Atacama Desert in Chile, where mineral-rich water is pumped into vast evaporation ponds and left for months in one of the driest inhabited places on Earth. The rest comes from hard rock mines in Western Australia. The refined material is shipped across the Pacific to cell factories in China and South Korea, assembled into packs and shipped again to the United States. It works for a decade and then becomes hazardous waste in a country where fewer than 5% of lithium-ion batteries currently get recycled. Now hold that next to a steel tank full of ordinary air that never leaves your property. The physics behind that tank was described in 1662. Robert Boyle, working in Oxford, published the relationship that carries his name. Reduce the volume of a gas while holding temperature constant and the pressure rises in proportion. Squeeze air into half its space and the pressure doubles. Squeeze it to a tenth and the pressure rises tenfold. That pressure is stored energy in its purest form. It does not decay. It does not need a firmware update. It does not require a server in California to authorize its own warranty. The air holds its charge until you open the valve. A compressed air storage system has 4 parts. A compressor, powered by your solar panels. A pressure vessel, which is the tank. An air motor, which converts pressure back into rotation. And a generator, if you want electricity at the end of it. No thermal runaway, no cell balancing software, no fire suppression requirement, no recycling problem in 15 years. So here's the number, and this is the part I promised you. Take a 120-gallon ASME vertical tank, which is 0.4 on 54 cubic meters, and fill it to 150 pounds per square inch. Run the calculation for the energy stored in that compressed air, and you get approximately 0.34 kilowatt hours. Now put an air motor and a generator on the end of it, which realistically returns somewhere between 30 and 50%, and you recover roughly 0.10 to 0.17 kilowatt hours of electricity. A Tesla Powerwall stores 13.5 kilowatt hours, which means that to match a single Powerwall in electrical storage, you would need somewhere in the region of 80 to 90 of those tanks, not one tank in the corner of a garage. 80 of them, plumbed together with all the fittings and all the safety equipment that implies. I want to be very direct about this, because I would rather you trusted me than built something that disappointed you. One propane tank is not a home battery. It will not run your house overnight, it will not carry you through a blackout, and anyone showing you a single tank beside a solar panel and implying otherwise has either not run the numbers or is hoping you will not. But that is only half the story, and the other half is genuinely worth your time. Because there is one thing this tank does extraordinarily well, and it is the thing every successful compressed air system in history has actually done. Stop converting it into electricity. Here is why that single change transforms the picture. When you turn compressed air into electricity, you pay a conversion penalty twice. Once when the compressor turns electricity into pressure, and again when the air motor and generator turn pressure back into electricity. Each stage bleeds away a large share of what went in. But if you use the air directly, as air, to do mechanical work, you skip the second conversion entirely. A pneumatic drill does not need electricity. Neither does an impact wrench, a sander, a grinder, a nailer, a die grinder, a paint sprayer, or a pneumatic water pump. That same 0.34 kilowatt hours, which looks pitiful as a battery, is genuinely useful as stored mechanical work. It will run air tools through a real job. It will drive a pump. It will do the thing you actually wanted done without ever touching a wire. Let me put real numbers on that, since this is where the tank stops being disappointing and starts being genuinely useful. An air impact wrench consumes roughly 4 cubic feet per minute in actual use, and a 120-gallon tank At 150, PSI holds around 160 cubic feet of free air. That is a substantial run of intermittent work before the pressure drops out of usable range. A framing nailer uses a fraction of a cubic foot per shot, which means hundreds of nails from one charge. A die grinder or a sander is thirstier, running continuously, and will drain that tank in minutes rather than hours. A pneumatic water pump is the standout. It runs slowly, it draws modest air, and it will lift water from a deep well without a single volt of electricity anywhere in the system. So the honest picture is a tank that runs intermittent tools comfortably, drives a pump beautifully, and struggles with anything that demands continuous high flow. That is exactly how compressed air has always been used by people who depend on it. And that is not a theory. It is the only version of this technology that has ever worked at scale in 4 separate settings, going back nearly 2 centuries. Start in 1857 in the Alps. Engineers began cutting the Fréjus rail tunnel beneath Mont Cenis, one of the most ambitious civil engineering projects of the 19th century. Teams working from the French and Italian sides had to drive through solid alpine granite. Hand drilling was impossibly slow, so they used pneumatic rock drills powered by compressed air piped in from outside the tunnel. The choice was not arbitrary. Steam engines could not run inside a tunnel since they consume oxygen and fill the workings with smoke and heat. Compressed air did the opposite. It delivered power, and it delivered fresh air, ventilating the tunnel as it worked. And the drills transformed the schedule, and the tunnel opened in 1871 after 14 years. It proved beyond argument that compressed air could deliver sustained industrial power in conditions where nothing else could. Now scale it to an entire city. In the late 1880s, an engineer named Victor Popp built a compressed air distribution network beneath the streets of Paris. It began with pneumatic clocks synchronized across the city by pulses of air traveling through underground pipes. Then it grew. That network went on to power elevators, printing presses, industrial lathes, sewing machines, and machinery in workshops across Paris. At its height, the company served thousands of customers through pipes running under the streets, and the system operated continuously until 1994. Read that date again. A compressed air utility, delivering mechanical power through pipes to paying customers in a major European capital, operating for more than a century and shutting down within living memory. Paris did not abandon compressed air because it stopped working. The network closed as local industry declined, and maintaining aging underground pipework stopped making financial sense. The detail worth holding on to is what that network was actually delivering. It was not sending electricity, it was sending mechanical power directly down a pipe to machines that ran on air. A workshop in Paris did not need a motor, a converter, or a generator on the wall. It needed a valve, and behind that valve was a citywide reservoir of stored work. Compressed air distribution predates the electrical grid, and for a period the two competed as rival ways of moving power around a city. Electricity won, and won decisively, since it travels further with far lower losses and does a wider range of jobs. But it did not win because compressed air failed to function. It won because a wire beats a pipe on nearly every axis except one, and that one is the axis you care about here, since a pipe stores its energy and a wire does not store anything at all. Now, utility scale. In 1978, engineers commissioned the world's first commercial compressed air energy storage plant at Huntorf in Lower Saxony, Germany. It stores compressed air in underground salt caverns and delivers on the order of 290 megawatts of electrical output. It has been running for over 45 years, and it is still in service today. In 1991, a second plant went online in McIntosh, Alabama, built by the Alabama Electric Cooperative, storing air in a salt cavern and delivering around 110 megawatts for many hours per discharge cycle. Both plants work for the same reason, and it is the reason that matters most for you. They do not use tanks. They use salt caverns, which are enormous, natural sealed voids, hundreds of meters underground with volumes measured in hundreds of thousands of cubic meters. The Huntorf caverns hold roughly 310,000 cubic meters. Your 120-gallon tank holds 0.454. That is a difference of over 600,000 times, and it is precisely why the utility version works and the single-tank version does not. Scale is not a detail in compressed air storage. Scale is the entire technology. Now, community scale, and this is the one that is genuinely instructive. Amish communities across Lancaster County in Pennsylvania, Holmes County in Ohio, and parts of Indiana run entire workshops on compressed air. They use engine-driven compressors to fill large ASME-rated tanks, then distribute that air through steel piping to the buildings that need it. That air runs table saws, drill presses, lathes, sanders, and submersible water pumps drawing from deep wells. Look carefully at what they are doing, because it explains everything in this video. They are not converting air back into electricity. They are using pressure to do mechanical work directly, which is the one application where compressed air is genuinely excellent. They arrived at the correct engineering answer, through constraint rather than calculation. And the internet has spent the last decade repeating their success while getting the mechanism exactly backwards. The Amish did not prove that a propane tank replaces a battery. They proved that, if you want mechanical work, you do not need electricity in the middle of it at all. If you want the full worked arithmetic for your own setup, including the tank sizing tables, the pressure and volume calculations, and the honest efficiency figures, everything is linked below. All the numbers shown rather than asserted. But before the build, there's a question worth answering, which is why you cannot simply buy one of these. The barrier is not physics, and it is not a ban, it is paperwork. The Inflation Reduction Act of 2022 created a 30% federal tax credit for residential clean energy, and standalone battery storage of 3 kilowatt hours or larger qualifies directly. On paper, a compressed air system storing electricity ought to qualify too. In practice, the credit is unreachable. Since no manufacturer has obtained a listing for a residential compressed air storage product, no installer network exists to certify the installation, and no permitting pathway has been established in most municipalities. Without a certified product and a licensed installer, no tax professional will put it on your return, and no appraiser will recognize it as an improvement to your property. A homeowner who installs a lithium battery receives a federal credit, a turnkey installation, a manufacturer warranty, an insurance rider, and added appraised value. A homeowner who builds a compressed air system in their garage receives none of those things, regardless of how well it performs. The market was never designed to exclude compressed air. It was designed around chemical batteries, and anything outside that shape is invisible. In a system where credits and certifications decide what gets built, invisible produces the same outcome as prohibited. Now let me show you how to build one. The storage vessel is an ASME certified propane tank, and the certification matters more than anything else on this list. ASME tanks are built from thicker steel with stronger welds than portable Dotty cylinders, and they carry a crucial advantage. A Dotty cylinder must be requalified every 12 years. An ASME tank is certified once at manufacture and remains certified for the working life of the vessel, which routinely exceeds 30 years. A new 120-gallon ASME vertical tank from a manufacturer such as Manchester Tank or Flame King runs $400 to $600 retail. A used or decommissioned tank from a propane supplier retiring older stock sells for $50 to $120, which is where the $90 figure in the title comes from. For the compressor, choose an oil-free electric model rated for at least 150 psi at continuous duty. California Air Tools and Makita both build reliable units in the $200 to $400 range. Oil-free is not a preference. Oil carried into long-term storage coats the inside of the tank, contaminates everything downstream. Add an inline moisture separator and a desiccant filter for $20 to $40, and treat that as mandatory rather than optional for reasons I will come back to in the safety section. For the delivery side, use black iron pipe, copper or aluminum tubing rated for compressed air, along with proper fittings and thread sealant. If you want mechanical output, a vane-type air motor from Gas Manufacturing or Parker Hannifin runs $150 to $300. If you want electricity anyway, couple that motor to a permanent magnet DC generator or a small automotive alternator. A complete functional system lands somewhere between $500 and $1,200. Now the efficiency catch, and this is the physics that limits every compressed air system ever built. When you compress air, it heats up dramatically. That heat is energy that came out of your compressor, and if you let the tank sit and cool to room temperature, that energy radiates away into your garage and is gone forever. Then, when you release the air, it expands and cools sharply, which is why an airline frosts up during heavy use. Those two effects together are why the round-trip efficiency of a simple home compressed air system sits somewhere around 20 to 40%, while lithium achieves roughly 90%. Large plants address this with heat management, and Huntorf burns fuel to reheat the expanding air. Advanced designs capture the compression heat in a thermal store and put it back during expansion, which is where the research is now focused. At home, you can capture some of that heat usefully by running the compressor discharge line through a coil in a water tank, which gives you hot water from a process that was otherwise wasting energy. That does not improve your electrical efficiency, and it does improve the overall value you get from every kilowatt hour you spend. Now the safety section, and I need you to take this one more seriously than any other in this series. Compressed gas is not comparable to compressed liquid, and this is the single most important thing to understand before you touch a tank. A liquid is essentially incompressible, so a tank full of liquid holds very little stored elastic energy, and a failure produces a leak. A gas is compressed, and it holds that compression as stored energy across the entire volume. A failure releases all of it in milliseconds. That means the failure mode of a compressed air vessel is violent, and it is genuinely capable of killing people. This is the reason industrial compressed air systems are surrounded by regulation, and it is the reason I'm spending this long on it. So here are the rules, and none of them are optional. First, a propane tank must be professionally purged before it is used for anything else. Residual propane vapor mixed with compressed air inside a sealed steel vessel is an explosive mixture, and this is a job for a propane service company with the correct equipment, not a garden hose and optimism. Second, never exceed the tank's rated working pressure and stay comfortably below it. Read the data plate on the vessel and treat that number as a wall. Third, fit a pressure relief valve sized for the tank and set to open below the rated maximum. These cost between $8 and $15, and this is the single most important component in the entire system. Fourth, never use PVC or any plastic plumbing pipe for compressed air. PVC becomes brittle under pressure cycling and shatters without warning, throwing fragments at lethal speed. Black iron, copper, or air-rated aluminium only. Fifth, manage moisture, which is the long-term killer of these systems. Compressed air carries water. Water collects in the bottom of the tank, and that water rusts the vessel from the inside where you cannot see it. Drain the tank regularly through the bottom valve, run that inline separator, and inspect the vessel over time. And sixth, if you are designing anything above 200 psi, or plumbing multiple tanks together into a manifold, involve a licensed mechanical engineer. That is not caution for its own sake, since manifolded vessels multiply both the stored energy and the number of failure points. Now the honest limitations, stated plainly. Round-trip electrical efficiency for a home system runs roughly 20 to 40%, against roughly 90 for lithium. Energy density is poor. One tank holds a fraction of a kilowatt hour, which is why the electrical case only works at cavern scale. It is mechanically complex, since you need a compressor, a motor, and a generator, which is far more moving parts than a battery. Those parts are rebuildable with hand tools, which a dead lithium cell is not, and that is a genuine advantage over decades. Compressors are loud, so if a neighbor's window faces your garage, plan for an insulated enclosure or schedule compression during daylight hours. And the storage itself does not self-discharge, since a well-sealed tank holds pressure indefinitely, which is one axis where it beats every chemical battery ever made. So here is the honest verdict, and it is not the one the title implies. As a replacement for a home battery, one propane tank is roughly 1% of the job, and you would need dozens of them to matter. As a store of mechanical power for tools, a pump, and workshop machinery, a single tank is genuinely excellent, costs almost nothing, needs no chemistry, and will still be working in 30 years when the third replacement power wall is on its way to a hazardous waste facility. The technology is real. The history is real. The 30-year lifespan is real. The only thing that was ever exaggerated is which job you should hand it. Here's a claim worth checking, and I would like you to check it. The Huntorf compressed air plant in Germany has been storing energy in salt caverns since 1978 without a single replacement of its storage medium. That is over 45 years of continuous service, and no lithium installation anywhere on the planet can make that claim. Then check the second half yourself. Look up the cavern volume at Huntorf, compare it to the volume of a 120-gallon tank, and you will understand in about 30 seconds why scale is the entire argument. So here's my question. If you had $500 in a garage, would you build a compressed air system that runs your tools for the next 30 years without a wire? Or would you put it toward a lithium battery that stores electricity properly and needs replacing twice in the same period? Drop your answer in the comments and tell me what you would actually run on stored air if you had it. I read everyone. Next time, I'm going to show you the pump that moves water uphill continuously, day and night, with no electricity, no fuel, and no solar panel, invented over 200 years ago and still running on farms today. Subscribe so you do not miss it, and remember that the technologies we abandoned were almost never beaten on performance. They were beaten on convenience.